Hello students, welcome you all to the doubt clearance sessions of Brainiacs Classes. So the first question that we are going to discuss here is, I hope you could see the question. Calculate the amount of water produced by the combustion of 16 gram of methane. Okay, so I have written the equation here. So methane means CH4 with combustion means that happens in the presence of oxygen. So CH4 plus O2, we know that any hydrocarbon containing carbon and hydrogen on complete combustion will become carbon dioxide and water. And you could see here it is becoming carbon dioxide and water, and on balancing it becomes 2 moles of oxygen and this becomes 2 moles of water. Okay, now how to solve this question, we will see that. Now what they are asking you to calculate the amount of water, correct? So first we will write the stoichiometric equation, stoichiometric ratio. So what is the stoichiometric ratio here? So if you see, the stoichiometric ratio is, I can say that becomes 1:2, 2:1:2. Correct. How will we write stoichiometric ratio? Basically, you know that from a balanced chemical equation we used to write stoichiometric ratio. Here 1 comes from methane, okay, 2 comes from oxygen, 1 comes from carbon dioxide and 2 comes from water. Now as per stoichiometric equation, we know that 1 mole of methane, okay, 1 mole of methane gives how much amount of water? 2 mole of water. So we will write that. So 1 mole methane can give what? Actually 2 mole of water. Okay, but in question they have given methane in the form of mass actually. So I know 1 mole of methane. What is the mass of 1 mole of methane? We know that 1 mole, so it is molar mass. So carbon 12, hydrogen 4. So 12 plus 4, 16. So I can say 16 gram. Okay, so 16 gram CH4, okay, gives what actually? 2 mole of water. So 2 mole means 1 mole of water has a mass of H2O, that is 2 into 1 plus 16, 18. So 2 into 18. So I can say it will give 2 into 18 gram water. So in question also they have asked you 16 gram of methane is giving how many gram of water. So my answer is, what is my final answer then? My final answer is 36 gram water. So the method here we need to follow is, first make the equation balanced, then write the stoichiometric ratio, then based on the stoichiometric ratio try to link which and all things needs to be compared. Here methane and water. So from that I write 1 mole of methane gives 2 mole of water. Then what I have done, 1 mole of methane is fortunately 16 grams. Sometimes they may asking 32 gram of methane. Then what you need to do, I know that 16 gram of methane gives 36 gram of water. To convert this to 32 gram of methane, I should multiply by 2 on both sides. Okay, so I hope students you understood how to handle this question. We will deal with next question. Okay, thank you. I hope you see the question now. The question here is, the number of water molecules is maximum in. You could see 4 options. Option A, 18 molecules of water, 1.8 gram of water, 18 gram of water and 18 moles of water. Okay, first of all I will tell why the examiner is putting a question like this. Here the examiner want to test you whether you are able to know the different units. Okay, that means the relation between mole, molecules, mass and number of moles. Regarding that, whether you have a clear idea or not. So then how to tackle this question? The best method is convert every unit or convert every stuff, every options into one single unit, so that comparing that it will be easy for you to get the answer. Okay, so let us try. First option given is 18 molecules of water. Okay, so let me try to convert every other units to number of molecules. Then it becomes easy for us to compare the 4 options. Okay, so let me write. So option A, they are giving here is 18 molecules of water. So we know that option A given here is 18 molecules of water. Okay, molecules of water. Now option B here, what is option B given here? 1.8 gram of water. So we need to convert this into number of molecules. So as per our standard formula, we know that, okay, 1.18 gram of water, that is the molecular mass of water. It will have how many molecules? It will have Avogadro number of Avogadro molecules of water. Correct. This is we are learning from our fundamental. Every time the molecular mass will contain the Avogadro number of or Avogadro molecules of water. So always it should be molecular mass in grams. Then it will have always Avogadro molecules of water. Now we know that 18 gram contains 6.022 into 10 power 23 molecules of water. But I need to find out in 1.8 gram of water. So how to do that? Divide by 10 on both sides. So this will become 1.8 gram. And when you divide here by 10, this will become 0.1 Na. Correct. 0.1 Na molecules you will get. Correct. So what is 0.1 Na? We know that 0.1 into 6.022 into 10 power 23. So I can say it is nothing but 6.022 into 10 power 22. Okay, now you compare. The first one has only 18 molecules. Now the second option has 6.022 into 10 power 22 molecules. That is very huge. Correct. Now we will come to option C. So coming to option C, you know that they have directly given 18 gram of water. Just now we have learned that 18 gram is the molecular mass of water. It will always have how many molecules? Na molecules of water. Correct. So Na molecules means how many molecules are present? Now we have that is 6.022 into 10 power 23. Correct. So Na molecules means I can say 6.022 into 10 power 23. Now tell me option B or option C is highest. We know that option C is highest. Correct. Now coming to option D, that is 18 moles of water. So I know the standard relationship between number of moles and number of molecules. 1 mole will have how many molecules of water, or 1 mole will have how many molecules? Avogadro number of molecules. So 18 moles means how much? So we can say 18 moles is equivalent to 1 mole is having Avogadro number. So 18 moles means 18 into Avogadro number, 18 into Na. So comparing the 4 options, I can easily say that 18 into Na means 18 into 6.022 into 10 power 23, which is a very huge number compared to A, B and C. So my answer should be which one? Option D. Okay, I hope you understood the question. Any doubt, please feel free to come back. Okay, so here we have a question. I hope you could see the question now. Elements X and Y combine to form 2 compounds XY and X2Y. Okay, find the atomic weight of X and Y if the weight of 0.1 moles of XY is 10 gram and 0.05 moles of X2Y is 9 gram. So this question is a very important question. So how to tackle this question? You will see that. Okay, so they are talking about 2 compounds mainly. What are the 2 compounds? The first one they are talking about the compound XY. Correct. So first we will see XY. So regarding XY, they are giving a statement like 0.1 moles of XY is 10 gram. That is 0.1 moles of XY is equal to 10 gram. Okay. We know from our fundamentals that 1 mole of any compound will weigh its molecular mass in grams. Correct. So we need to convert this into 1 mole so that particular weight will be equal to molecular mass expressed in grams. So molecular mass expressed in grams is equal to molar mass, that is the mass of 1 mole of the substance. So we will convert 0.1 moles to 1 mole. How we can do that? Multiply by 10 on both sides. So this will become 1 mole of XY is equal to 100 gram, correct? So what is the meaning of this? 1 mole of XY means what actually? 6.023 into 10 power 23 X plus 6.023 into 10 power 23 Y. If you add this much atoms of X and Y, that will weigh 100 gram. So I can write Na X plus Na Y is equal to 100 gram, correct? Now I know from my schools there is a fundamental relation between unified mass and gram. I know that 1 unified mass is equal to 1 by Na grams. This is something you should remember actually. This is a formula we are learning actually. So this is something like a relationship between U or AMU, both are correct. So 1 AMU or 1 U is equal to 1 by Avogadro number grams. Okay. Now I am dividing the whole equation 1 by Na. So if I am dividing whole equation by Na, this will become X plus Y is equal to 100 by Na grams, correct? And we know from equation 2, 1 U is equal to 1 by Na grams, correct? So I can rewrite the equation as X plus Y is equal to 100 into 1 by Na gram. So this can be further written as X plus Y is equal to 100 U. So this part I have substituted. 1 by Na gram is equal to 1 U. Okay, so this is how for XY we have done. Now similarly on going for next one, that is the X2Y, we will see. So for X2Y, what they have given? X2Y they have given 0.05 moles of X2Y is 9 gram. Okay, so 0.05 moles of X2Y is equal to 9 gram. Now similarly if we are doing, I am converting this to 1 mole, then we need to divide by 0.05 on both sides. So this will become 1 mole of X2Y is equal to 9 divided by 0.05, correct? 9 divided by 0.05 gram. So that means what actually I can write, similarly if I go through like in XY, I can write 2x plus y, 2x plus y is equal to 180, okay, 180 U. So this is equation, I can say 4, and this is my equation 3. Now if I solve 3 and 4, I will get the answer for X and Y. So let's see how to solve that. Okay, now just I'm rubbing this. Okay, so we have finally 2 equations we arrived at. Now if we solve these 2, we will get the value of or atomic weight of X and Y. So we see how to solve this. Okay, now X plus Y is equal to 100 U, correct? Next one is 2x plus y is equal to 180 U, correct? So we know from maths how to solve this. So if we are subtracting it, then what we will get? Minus x is equal to minus 80 U. So that means x is equal to 80 U. So if x is equal to 80 U, substitute in equation 3, so that you will get y is equal to 20 U. So we got the atomic weight of X and Y. So my answer is option B. So I hope you could see the question very clearly. The question here is the number of atoms present in 0.1 mole of a triatomic gas is. Okay, so they have not mentioned the gas. So let's assume the gas is A3. Okay, so A3 is my triatomic gas. Okay, so here why I am assuming A3? It can be anything arbitrary because it is not mentioned, so I am mentioning it as A. I kept 3 because it is a triatomic gas. And look at this question. This is they are asking you the number of atoms present in a molecule actually. So how to calculate the number of atoms if a molecule is given? In that case, we introduce the concept of atomicity. So we say atomicity. So what do you mean by atomicity? Atomicity gives the number of atoms present in one molecule of a compound. So here in the case of atomicity of A3 is what actually, how many atoms are present in one molecule of A3? I can say 3. So my atomicity is 3. So generally speaking, the number of atoms is equal to, I can say, number of molecules multiplied by atomicity. Okay, so this is a general thing you should remember. Whenever they are giving you molecule and they are asking you the number of atoms, the best method is first to identify the number of molecules, calculate the number of molecules and multiply by atomicity. So in the question, we know that from our fundamental concept, 1 mole, okay, 1 mole of any molecule, let it be A3, 1 mole of A3 will have how many molecules? This we have learned in our fundamental chemistry. So we know that it will have 6.022 into 10 power 23 molecules. That is Avogadro number of molecules. But in our question, they have asked in 0.1 moles of the triatomic gas. So how can you convert 1 mole to 0.1 mole? Divide by 10. So on dividing by 10, this will become 0.1 mole of A3. So when you divide by 10, divide on the LHS and RHS. So this will become 6.022 into 10 power 22. Okay. Now we know the number of molecules. Correct. We know the number of molecules. Now how to find the number of atoms? We will use the same formula. So the number of atoms is equal to number of atoms in 0.1 mole of number of atoms in 0.1 mole of number of atoms in 0.1 mole of A3 is equal to, tell me, number of molecules. We have calculated it, 6.022 into 10 power 22 multiplied by 3. Atomicity is 3 for A3. Now this will become 18 into, approximately 18 into 10 power 22. Now if you are looking at the options, there is no option like 18 is present, but 1.8 is present. So we will divide by 10 and multiply by 10. So when you divide and multiply by 10, this will become 1.8 into 10 power 23 atoms. So tell me which option is corresponding to this. That is option A. Option A seems to be the right answer. This question I feel it is very important because it has not asked for Neet for the previous years. So I will just read the question. Chlorine is prepared in the laboratory by treating manganese dioxide with aqueous hydrochloric acid according to the reaction given below. How many grams of HCl react with 5 grams of manganese dioxide? Okay, so this is the question. So from this we could see here the equation is balanced actually. So if you see here 4 hydrogens are there, here also 4 hydrogens are there and 4 chlorine atoms, and here we could see 2 chlorine atoms of MnCl2 and another 2 chlorine atoms are present in chlorine molecule, and 2 oxygen atoms are there, and MnO2 there are 2 oxygen atoms. So it is a balanced chemical equation. Okay, now listen here. The main thing here is they are asking you how many HCl, that is grams, mass of HCl. They are asking how many grams of HCl you need for reacting with the 5 grams of manganese dioxide. Now many students will have doubt. They will come and ask me, sir, how will we know whether a limiting reagent is present in this question or not? I always say to my students that if there is only given quantity is given only for one stuff, that is manganese dioxide alone, they have given the value 5 gram. That is given is the mass of only one reactant is given. In those cases, limiting reagent will not be present. we will take hydrochloric acid, we will calculate it. Okay, so this is an important point to remember. If for one reactant only they have given the mass or number of molecules or anything, in that case there will not be any limiting reagent. Now the standard procedure is we need to balance the chemical equation, but for this question they have given the balanced chemical equation, so we will do this by stoichiometric method. So now tell me which and all quantities we need to relate here. We need to relate here between hydrochloric acid and manganese dioxide. So as per the balanced chemical equation, what is the stoichiometric ratio of this reaction? Okay, I will write the stoichiometric ratio. So if you see the stoichiometric ratio, we could see the value is 4:2:2:1:1. Okay, from this I know that 4 moles of HCl needed 1 mole of MnO2, manganese dioxide. Correct? Now what is 4 moles of HCl? We need to take it in mass. I know that 4 into mass of 1 mole of HCl, how much it will weigh? 1 plus 35.5. so this much gram HCl needs 1 mole of MnO2. So what is the mass of manganese? We know it is 55 plus oxygen, 16 into 2, 32. So this much gram of MnO2. Okay, so this was 55 plus 32 will be its molar mass because it is 1 mole. Now 36.5 will be the molar mass of HCl. 4 moles are there, so we are multiplying by 4. Okay, so now what is this value? Will become 4 into 36.5. This will come around 146 gram. 146 gram HCl needed. Okay, needed how much gram? 50 plus 30, 80, 87. Correct, 87 gram MnO2. So this is what we are deriving from stoichiometry. Now what they have asked, in what they have given in the question, 5 gram of manganese oxide. So from this we know that 87 gram MnO2 needed 146 gram HCl. But in the question they are asking 5 gram of manganese oxide, manganese dioxide needed how many gram HCl. So what we will do, first we will convert 87 gram to 1 gram. How you can do that? Divide by 87. So this will become 1 gram MnO2. So when you divide by 87 gram, this will become 1 gram. When you are dividing on the RHS, divide on the LHS also. So this will become 146 by 87 gram HCl. Now read it. 1 gram MnO2 needed 146 by 87 gram HCl. But are they asking 1 gram MnO2? They have given you 5 gram MnO2, 5 gram manganese oxide. So how can you convert 1 gram MnO2 5 gram? Multiply by 5. So this will become 5 gram MnO2. When you are multiplying on the RHS, multiply also on the LHS. So this will become 146 by 87 into 5 gram HCl. So I can say that this is my answer. So this value will be my answer. So what is that value actually? So if you check that value will come around 8.4. So this value, I will write it in another color. So this value will come around, okay, this will be 8.4 gram. So my answer is 8.4 gram HCl. So 5 gram of MnO2 needed 8.4 gram HCl for the reaction to happen. So this is the basic way with which we do questions of this type. Okay, and always remember, if there is only one quantity, one reactant's mass, number of molecules or anything is given, there is no concept of limiting reagent. I hope you understood the explanation. If you have any doubt, please feel free to come back. Here we are going to deal with a next question. So I hope you could see the question here. I will just read it. Assuming fully decomposed, okay, that means full decomposition, the volume of carbon dioxide released at STP on heating 9.85 gram of barium carbonate will be. Okay,
So this question is very important actually. Why we say is there is no equations given. So we can easily write the decomposition reaction of barium carbonate. So can you tell me what will be the decomposition reaction? I will just write. I can say barium carbonate BaCO3 will decompose on heating to give you barium oxide, okay, plus carbon dioxide. Okay. Now I am keeping it in gas because they are asking you the volume. Okay. Now if you see, this is a balanced chemical equation, so we don't need to balance it further. So again we will do this question by stoichiometric method. So as per the stoichiometric method, what will be the stoichiometric ratio here? So if I write stoichiometric ratio here, you could see the stoichiometric ratio is equal to, so stoichiometric ratio will be 1 1 1, so it will be 1 is to 1 is to 1, correct. Now with what and all terms we need to relate it here, they are trying to relate between carbon dioxide and barium carbonate. So this term should be related with the carbon dioxide, and barium carbonate they have given in mass, and carbon dioxide they are asking you in volume. So first of all we will write in terms of mole. We know that from stoichiometry, 1 mole 1 mole barium carbonate produces on decomposition 1 mole carbon dioxide, correct. So 1 mole barium carbonate means what will be its mass? We know atomic mass of barium is given as 137. So we can say 137 plus what is the mass of carbon? 12, then oxygen 16 into 3 48, correct. So this much gram barium carbonate will give you 1 mole carbon dioxide. So how you can express it in terms of volume? I know that at STP, any gas, 1 mole of any gas at STP will always occupy a constant volume, that is 22.4 liters. Please remember, it is 1 mole. 1 mole of any gas will occupy 22.4 liters at STP. This is very important. Okay. Now, we know that if you add all these things, we will get 197 gram. So 197 gram barium carbonate will give you 22.4 liter at STP, 4 liter carbon dioxide. Now, what they are asking you how much 9.85 gram of barium carbonate will give. So what we need to do, first we will convert this 197 gram to 1 gram. So how can you do that? Divide by 197, so that this will become 1 gram barium carbonate. You are dividing by 197, do it on both sides. So this will become 22.4 divided by 197 liter CO2. Now, now you have obtained for 1 gram barium carbonate how much liter of carbon dioxide is obtained. Now we need to convert this 1 to which value? 9.85. What you need to do? You should multiply by 9.85 on both sides, LHS and RHS, so that this will become 9.85 gram barium carbonate, okay, will give you 22.4 divided by 197 into 9.85 liter CO2. So what is this value? So I will write it with another color, okay. So that value, it will be, so that value will be around 1.12 liter CO2 at STP. So I hope you have understood this. The only thing to remember here is it is again checking whether you know the basic stoichiometric concept, whether you know to balance the chemical equations, and whether you know the fundamental relationship between mass, volume, number of molecules. All those things are tested in this question. Now you could see a question here in the screen. Okay, I will first read the question. So what is the mass of the precipitate formed when 50 ml of 16.9 percentage solution of AgNO3 is mixed with 50 ml of 5.8 percentage NaCl solution? Okay, so this question is one of the good question that came for Neet already. And why this question is very important? Because it comes under the category of stoichiometry question only, but instead of giving the number of moles or number of molecules directly, they have given the quantity in a different way, like 50 ml of 16.9 percentage solution. So it is mass by volume they have mentioned. Okay, so first we will try to write the equation, what is happening and what is the precipitate here. Then we will try to identify, or we will try to convert this into the given quantity into number of moles. Okay, so we will start with writing the equation. So they are talking about AgNO3. Okay, so they are talking about AgNO3. Okay, AgNO3 getting treated with NaCl, so that what you will be getting, you will get AgCl, and NaNO3. Correct? Now, the first thing to understand here is what is the mass of precipitate formed. So I know that out of this the solid precipitate here is so AgCl. This is the first understanding you need. So they are asking about the mass of AgCl that is formed during the reaction, and we know this is a balanced chemical equation. Correct? So what is my stoichiometric ratio? Tell me. So my stoichiometric ratio stoichiometric ratio is equal to 1 is to 1 is to 1 is to 1. Correct? Now what is given here? So given here is AgNO3 solution, but have they given in terms of number of moles? No. So we want to convert that into number of moles. So how we will do that? So they have told 16.9 percentage. So they told here 16.9 percentage W by V AgNO3. What does this mean actually? So if you understand this perfectly, then this question becomes very easy actually. So this means 16.9 gram AgNO3 is present in what actually is present in 100 ml of solution. Correct? Okay, so since it is W by V, but they also mentioned that it is not just 16.9 percentage. They are telling they have taken a solution that is only 50 ml. Okay, why? Because they are telling formed with 50 ml of. So that means we know here 16.9 gram of AgNO3 is present in how much ml of solution? 100 ml of solution. Now we need to find out in 50 ml how much. So we will do like this. So from our understanding, 16.9 gram is present in how much ml of solution? 100 ml of solution. So tell me in 50 ml how much will be present? How to convert 100 to 50? Divide by 2. So this will become 50 ml of the solution. 50 ml solution. So in divide by 2 on LHS and RHS. So this will become 8. If I am dividing by 2, this will become 8, and this will become 45. Correct? 8.45 gram is present in 50 ml. Now it is easy to calculate the number of moles of AgNO3. So how can you do that? Number of moles of AgNO3 is equal to number of moles of AgNO3 is equal to, we know that weight in gram divided by molecular mass. So weight in gram, we know 50 ml, in 50 ml solution how much gram is present? 8.45 divided by molecular mass of AgNO3. So how much it will come? The molecular mass of AgNO3, I can say the molecular mass of AgNO3, it will come around 169.8. 169.8. 0.8, and if you calculate this you will get the number of moles. So this will come around 0.049. Okay, so just now I have calculated the number of moles of AgNO3. So similarly, I need to calculate the number of moles of what actually NaCl also. So we will do that next. Okay. So I will rub this so that it is easy for you to calculate the next one. Okay. Okay, this question is just if you understand it in the perfect way, this is one of the easiest question, because this is the way they usually what they will do, they will create questions. So that is very important, understanding the question in the right sense. Okay, now we will try to do the NaCl solution. Okay, what they have told about NaCl solution, they are telling 5.8 percentage. So what does that mean? Tell me. That means 5.8 gram of NaCl is present in present in, tell me, present in, it's percentage, right? So present in, I can say 100 ml solution, but they have told very clearly that how much amount of solution they have taken for mixing, 50 ml only. Now in 50 ml, tell me how much gram will be present. So you know how to convert 100 ml to 50 ml, divide by 2. So if you divide by 2 here, how much it will come? So I can say 2.9. So I can write 2.9 gram NaCl is present in how much? Tell me. Present in 50 ml solution. So why you are finding out in 50 ml solution? Because you are taken a solution that is only 50 ml. Okay. Now tell me the number of moles of NaCl. So number of moles of NaCl is equal to, tell me, weight in gram. Weight in gram is nothing but 2.9 divided by the molecular mass of NaCl. So how much it will come around? It will come around 58.5. And if you calculate this value, this will come around again 0.04. Okay, approximately speaking 0.049 it will come. Okay, so we understood that the number of moles of AgNO3 and NaCl is almost the same, 0.049. So tell me, as per the stoichiometry, we know that 1 mole of AgNO3 and 1 mole of NaCl can produce how many moles of AgCl? 1 mole of AgCl. Correct. So we can write that. So I will write it in another color so that you will get a fair understanding. Okay, so I will write here 1 mole AgNO3 and 1 mole NaCl can produce what actually? 1 mole AgCl. Correct. Now tell me how many mole you have, how many mole of AgNO3 is given to you? 0.049. Correct. So I can write 0.049 mole AgNO3, and you know the same amount is present for NaCl. Suppose if it is a different value, then we need to find out the limiting reagent. In this case, that is not required because both values are almost same, because 1 mole of AgNO3 and 1 mole of NaCl will produce 1 mole AgCl. So similarly, 0.049 mole AgNO3 and 0.049 mole NaCl will give how many mole of AgCl? Very easy. We can say it is 0.049 mole AgCl. Okay. So I got the answer of mass of the precipitate in terms of mole. I need to convert this mole value to mass. So how can we do that? We will check how to do that. First we will rub this. Okay. Then we will try to see how to do that. Okay. So I hope this is this understanding is, this explanation is very much clear for you. So the detailed understanding. So how this mass percentage everything is coming, this is present in our lectures actually. So you can subscribe those lectures, you can contact Brainiacs Classes. There you will get the detailed lectures, and there you will get a very much clear understanding of each topic one by one. Okay, so the last step we are going to find out the number mass of the precipitate. Okay, so we can say, so I will write that finally. So the mass of the precipitate, okay, we'll take a new color here. We'll take this color. Okay. Okay. So I can say the mass of the AgCl precipitate. Okay, the mass of the AgCl precipitate. How we know, how can we find out? We know that number of moles is equal to mass divided by molecular mass. So mass of the precipitate will be equal to what? Number of moles multiplied by what? Molecular mass. Correct? Okay, so number of moles we have already find out. This was 0.049, which is multiplied by the molecular mass of AgCl. So tell me, what is the molecular mass of AgCl? How can you calculate that? Ag, they have given 107.8 plus 35.5. So this will come around 143.3. So if you calculate this value will be around 7 gram. So my final answer is 7 gram. So I hope you understood how to do this question. You can expect similar questions for Neet, upcoming Neet. They can give you the given quantity in different ways, either in terms of mass percentage or mass by volume percentage, or number of moles, number of molecules, or it can be volume. Okay, it is that you should convert this into number of moles, and if limiting reagent is there, you should calculate that and finally calculate the output. So that output also can be in any ways they can ask, either in mass or in number of moles. So they can create n number of questions out of this. This is a very important question, so please learn this and prepare well for your NEET exam. So we have a question here, and this question is one of the most important question, and I will just read the question. Okay, try to understand the question. So 25.3 gram of sodium carbonate Na2CO3 is dissolved in water to make 250 ml of solution. If sodium carbonate dissociates completely, find the molar concentration of sodium ion and carbonate ion. Given the molar concentration of Na2CO3, given the molar mass of Na2CO3 is equal to 106 gram per mole. Okay, so on doing this question, how to understand this? First of all, I will try make you understand the question. Okay, then we will try to do this. Okay, so they are telling they are using sodium carbonate. Okay, correct. So they are using sodium carbonate and they are dissolving this in water. Okay, so that means that it is added to water. So when sodium carbonate is dissolved in water, what is happening? They are telling sodium carbonate dissociates. So dissociation happening. Correct. So first we will try to understand. Dissociates, it's a not partial dissociation, it's a complete dissociation. Dissociates completely. Correct. So let's see how this will happen. Okay. So if sodium carbonate is dissociating, I can say 1 mole Na2CO3 on dissociating will give you 2 Na plus, correct, 2 mole of Na plus and 1 mole of CO3 2 minus ion, correct. That means 1 mole Na2CO3 on dissociation gives 2 mole of Na plus and 1 mole of CO3 2 minus. Now we will see. The question says about sodium carbonate as a solute which is dissolved in a solvent water. Now they say 250 ml of the solution, and in the question what they are asking you to find out, very important, they are asking you to find out the molar concentration, very important. So molarity is a very important factor. Molar means you need to find out in 1 liter basically. So let's calculate the molarity of the solution. We know molarity is equal to, tell me, weight in gram of the solute divided by molecular weight of the solute multiplied by 1000 by volume of the solution in ml. Since it is ml, I am multiplying by 1000. So on substituting, we will get 25.3, correct, divided by molecular weight of the solute is given as 106 into 1000 divided by volume of the solution is given as 250. So if you do this calculation, you will get the answer as 0.955 molar. So what is the meaning of this 0.955 molar means? That means 0.955 moles of Na2CO3, okay, is present in 1 liter of solution. You might have remembered that standard definition of molarity. If somebody says 5 molar solution means what? 5 moles of the solute is present in 1 liter of the solution. Now why we have finding here molarity here? Since they are asking me the molar concentration of sodium ion. So here also I need to find the molar concentration of sodium ion. So molar concentration of sodium ion means I need to find the number of moles of sodium ion that is present in 1 liter of the solution. This is very important. Now I know that 0.955 moles of Na2CO3 is present in 1 liter of the solution, correct? But I know that 1 mole Na2CO3 on decomposition will give 2 Na plus. So we have how many Na2CO3 is there? 0.955 Na2CO3 is there. So 0.955 Na2CO3 means each mole of Na2CO3 will give 2 Na plus. So my concentration of Na plus will be equal to what? Molar concentration of Na plus will be equal to what? 0.955 into 2, because 1 mole will give 2 Na plus. Correct. I have 0.955. So if there is only if Na2CO3 on dissociation gives only 1 Na plus means we know that 0.955 into 1 will come. So here 0.955 into 2. So that answer will come around 1.910 molar. Now similarly, can you tell me what is the molar concentration of CO3 2 minus ion? I have how many Na2CO3? 0.955. So surely there will be how many CO3 2 minus ion? Minimum it will be 0.955. And we know that Na2CO3 on decomposition, 1 mole of Na2CO3 on decomposition will give only 1 mole of CO3 2 minus. So 0.955 moles of Na2CO3 on decomposition will give how many CO3 2 minus? 0.955. Correct. So my answer will be 0.955 into 1, and that will be 0.955 molar. Okay, I hope you understood the question. Always take care. If it is complete dissociation, identify how the dissociation happens. One easy way here is take the 2. Here Na2 means 2 Na plus will come. And take the charge of CO3. Here we know that it is plus charge. 1 is there. So that's why plus is coming. And CO3, please listen, there is nothing, there is only one CO3 is present. That's why 1 is coming here. And here 2 is there. That means that is the charge here, 2 minus. And it is neutralized. 2 Na plus means net positive charge is 2 plus, and 1 CO3 2 minus means net charge is 2 minus. So 2 plus and 2 minus, net charge will be equal to 0. This question is also a little bit important actually. And here also this question also comes under the category stoichiometry. So stoichiometry calculations are one of the important topics for NEET. So surely you need to learn that and go for the exam. Okay. So we will see how to understand this question first. So what is the question here? 10 gram of hydrogen and 64 gram of oxygen were filled in a steel vessel and exploded. Full stop. Calculate the amount of water produced in this reaction. And you need to find this amount of water in terms of mole. Okay, I have not given the options here. So you want to calculate this amount of water in terms of mole. Okay, MOL. That is what is important here. So here you know that hydrogen and oxygen is reacting, correct? So let me first try to write the reaction. Okay, so hydrogen, you have hydrogen H2 reacting with oxygen O2, giving you water H2O. I know that this is not a balanced chemical equation. So if you are following stoichiometric method, the most important step to be remembered here is make the equation balanced. Okay, how can you make the equation balanced? You have two hydrogen, here also two hydrogen, here two oxygen, but here one oxygen. So I am adding two here. So I now have two oxygen, but I have four hydrogen. So to balance that, I will keep two here. So 2H2 plus O2 giving 2H2O. Now it is balanced. Correct. Okay. Now this is my balanced chemical equation. Now I will try to write the stoichiometric ratio. Okay. So stoichiometric ratio will be, I can say that will be equal to 2 is to 1 is to 2. What is stoichiometric ratio? Basically the coefficient of a balanced chemical equation. So here it is 2, here it is 2, okay, here it is 1, okay, and here it is 2. So that is 2 is to 1 is to 2. Okay, now what is the what is the importance of finding the stoichiometric equation? With this I can write my standard relationship. I right now know that 2 moles of hydrogen needed 1 mole of oxygen to prepare what actually 2 mole of water. This is what you know, fundamental thing you know. Now we need to find what is given to you. So given to you is what? Very important. Given. Okay. So given to you is 10 gram hydrogen. Correct. So it is given in mass. That is also very important. And what is the other thing given to you? 64 gram oxygen. Correct, and that is also in mass. This is the wonderful thing, they have given you in mass and ask you to find the water in terms of mole actually. So this is where they are checking whether you know how to convert mass to mole also. So first what we will do is we will convert this mass in terms of mole. Okay, how to do that? To find the number of moles we should do the weight in gram, that is 10 gram, divided by molecular weight of hydrogen, that is 2. So I know 5 moles. Correct. So oxygen weight in gram given is 64 divided by O2. We know oxygen 16. So 16 into 2, 32. So since it is oxygen molecule, 32 is coming. So 2 moles. Now comes the most important section. You have two given quantities. Whenever two given quantity is there, there is a chance of limiting reagent. So first to check which is the, we will find out which is the limiting reagent out of hydrogen and oxygen. So and I will teach you a shortcut regarding how to find the limiting reagent. The best method you need to do here is for always calculate the number of moles. Okay, and when you get the number of moles, divide the number of moles by the stoichiometric coefficient of that thing. So here hydrogen, the stoichiometric coefficient is 2. So I will divide 5 by 2. So you will get a value 2.5. Correct. Now next thing, take oxygen and you got the number of moles of oxygen as 2. So take 2, divide by the stoichiometric value, that is 1. So 2 by 1 is equal to 2. And compare these two numbers. Which is the lowest number out of this? I know that 2.5 and 2. The lowest number here is 2. So that means this species is my limiting reagent. That means who is my limiting reagent? Tell me finally. Oxygen is the limiting reagent. Now, whenever you have found out the limiting reagent, you know that what is limiting reagent basically? Limiting reagent is that particular reagent which get completely consumed in the reaction. That means there will not be any reactant left behind, or there will be no species of oxygen will be available after the reaction, and hydrogen will be left behind. Now I can say, if a particular species is a limiting reagent, then that species will determine how much amount of product needs to be formed and how much amount of other reactant needs to be used. So here oxygen is my limiting reagent. I will write here oxygen is the LR. You always use the term LR for limiting reagent. Okay. Now, with respect to oxygen, now I will speak with the stoichiometry. Now, tell me, with respect to oxygen, I know that 1 mole oxygen, 1 mole O2. This is based on stoichiometry I am writing. Tell me, 1 mole of O2 produces, 1 mole of O2 produces, tell me how much mole of water? 2 mole water as per stoichiometric ratio. 2 mole water. Correct? Now tell me 1 mole O2 needs, what it needs? It needs 2 mole hydrogen. Okay, to produce 2 mole of water. Now in this question, I only want to find out how many moles of water is produced. Correct. So I will only speak with respect to water. So 1 mole O2 produces 2 mole of water. Hello. Yeah. So here 1 mole of O2 produces 2 mole of water. I will use a highlighter so that you will get a fair idea. Okay. Yeah, I will use this highlighter. Fine. Now you could see here 1 mole O2, 1 mole O2. Okay. So 1 mole of O2 is giving me how much mole of water? 2 mole of water. Correct. Now tell me, for us it is given 2 mole, because given is 2 mole. So tell me, to convert 1 mole to 2 mole, what we should do? Multiply by 2. So this becomes 2 mole of O2. So 2 mole of O2, if you multiply here also by 2. So it will give 4 mole of water. So my answer here is 4 mole of water. Suppose in the exam they may ask how much mole of hydrogen is used in the reaction. Then I know that 1 mole of O2 needs 2 mole of oxygen. So tell me 2 mole of oxygen. I told with limiting reagent only we need to calculate everything. So 2 mole of hydrogen needs how much? Multiply by 2. The answer will be 4 mole of hydrogen. Now we have already 5 moles of hydrogen given to you. So how much will be left behind in the reaction medium? 5 minus 4, that is 1 mole of hydrogen will be left behind in the reaction medium. So we have a new question in front of you. I will read the question. Please try to understand. The question here is, 1 gram of magnesium is burned with 0.56 gram oxygen in a closed vessel. Which reactant is left in excess and how much? Okay, so I will tell the summary. The summary is, you have a reaction where magnesium is burned with oxygen. So what is the expected reaction here? Okay, so we'll try to first write the reaction. Okay, so you have magnesium, correct? It is burned in presence of oxygen, O2. So you will get, we know the fundamental reaction is magnesium oxide, correct? So if I am going to balance this reaction, you know that I will put it here 2 because 2 oxygen atoms are there. So here I need to keep 2, correct? So can you tell me now the stoichiometric ratio of this reaction? So I can write the stoichiometric ratio is equal to, we know that stoichiometric ratio is usually written for a balanced chemical equation. So the coefficient of each reactant is considered as the stoichiometric ratio. So here the stoichiometric ratio will be 2:1:2, correct? Okay, now what is given to you? This is stoichiometric ratio. Now given to you is, we will write that separately, given. So given to you is, there is magnesium is there, one of the reactant. So how much is given to you? Magnesium, it is given in the form of mass, and that is 1 gram, correct? Now the other thing is oxygen. O2 molecule, it is also given in terms of mass, that is 0.56 gram, correct? Now we usually, whether mass is given or anything, we usually convert this into number of moles. So how can you convert 1 gram to number of moles here? You need to do the given mass by molecular, by, if it is atom we will say atomic mass, if it is a molecule we say molecular mass. Okay, so here 1 gram divided by the atomic mass. So the atomic mass of magnesium is how much actually? We know that that is 24 gram per mole, correct? Gram mole raised to minus 1. So what will be the answer? If you divide 1 divided by 24, how much it will become? So this will come around 0.0416 mole. So first quantity we have converted into mole. Now the next one, similarly, tell me, how can you convert this into mole? The given mass, that is 0.56 gram, correct, divided by the molecular mass, since it is molecule. So we can say molecular mass 16 into 2, 32 gram per mole, mole raised to minus 1, correct? So if you divide this, you will get a value 0.0175 mole. Now this is what given to you for this reaction to happen, that is 0.0416 mole of magnesium and 0.0175 mole of oxygen. Now as per stoichiometry, tell me how much how much mole of magnesium is reacting with how much mole of oxygen to produce how much mole of magnesium oxide. I know that as per stoichiometry, 2 mole, correct, 2 mole magnesium needs, tell me, 1 mole oxygen O2 to produce, I can say, to produce what? 2 mole magnesium oxide, correct? Now what they are asking in the question, which reactant is left in excess and how much? So they are telling that when you are given magnesium of this much quantity, that is 0.0416, and O2 of the quantity 0.175, one of the reactant will be left in excess. That means there is a limiting reagent in this case. Whenever there is 2 reactant and the given quantity is given for 2 reactants, always there is a possibility of limiting reagent. Okay, so we will check how to do this limiting reagent here. So I have a shortcut for you to find out the limiting reagent. To find out the limiting reagent, what you need to do is take the first case, that is magnesium. Okay, take its number of moles. What is the number of moles? 0.0416. okay, divide by the stoichiometric value, that is 0.0416 divide by the stoichiometric coefficient is what actually? For magnesium it is 2. So tell me how much it will come? 0.0208, correct? Now similarly do it for oxygen. Okay, so for oxygen it will come like, okay, what is the number of moles? 0.175. so what you need to do, take this value 0.175 and divide by the stoichiometric coefficient, that is 1. So we know that the value here is 0. Okay, there is a 0 missing here, so you should add that. So 0 point here also 0.175. So I can say 0.0175, correct? Now compare these two values. Compare this. Which one is the lower value? So I could understand that 0.0175 is the lower value. In that case, this will be my limiting reagent. Understood? So if this is the limiting reagent, now how we can proceed? I can say that oxygen will be controlling the entire reaction. Correct. So who will be left in excess? Now I got the first part of that answer. So which reactant is left in excess? So we know that limiting reagent is that species which is completely consumed, used up in a reaction. So if oxygen is completely consumed, who will be left in excess? Magnesium. Correct. So we will write here. Okay. So we will write here oxygen is the limiting reagent. Oxygen is the limiting reagent. So magnesium will be left excess. Will be left excess. Correct? Okay. Now, if you see here, they have also asked which reactant is left in excess and how much is also they are asking. So we will calculate that. We know that if oxygen is the limiting reagent, everything will proceed according to oxygen. Correct. So we can say that as per, we will first start with stoichiometry of oxygen. We know that 1 mole. So we say now 1 mole oxygen, okay, produces 1 mole oxygen produces what it will produce? 2 mole magnesium oxide. Correct. Now tell me the other way. 1 mole O2 needs tell me 2 mole magnesium. Correct. This is for 1 mole. This information we have written with respect to stoichiometry. Now, how much mole of oxygen you have? You have 0.0175. Correct. So now we will speak with respect to that. So next we will write 0.0175 mole O2 produces. We will go through all the part so that you will, if they ask how much amount of magnesium oxide produced, then also you can do this. 0.0175 mole of O2 produces. So we know that 1 mole O2 is producing 2 mole. So 0.0175 mole O2 means what? You need to multiply 1 with the 0.0175. So if you are multiplying here, multiply on the right hand side also. So you can multiply 2 into 0.0175 mole magnesium oxide will be produced. So what is that value? So if you calculate that value, it will be coming around. So we will just calculate that. Okay. So that value will be approximately, I can say 0.0175 multiplied by 2. So this will come around 0.035. So I can say 0.035 mole magnesium oxide will be produced at the end of the reaction. But this is not the question. They are asking how much magnesium is left excess. Okay. So we will calculate how much magnesium is used in the reaction. So we know that 0.0175 mole of O2, correct, is used. So that means 1 mole O2 needs 2 mole magnesium. Now tell me 0.0175 mole O2 needs how much? 1 mole is requiring that. So if you need 0.0175 mole O2 means multiply by this number on LHS and RHS. So this will become 2 into 0.0175. So again you will get the same answer, that is 0.035 mole magnesium is used. Correct? Is used. Now tell me how much magnesium will be left excess. So we can say magnesium which is left excess is equal to initial quantity. What was the initial quantity you have? So what is given to you? That is the initial quantity. Okay, the initial quantity given to you
is what actually? So here magnesium which is left excess is equal to initial quantity minus final quantity. So the initial quantity, if you see here, we have already calculated, that is 0.0416, correct? So if you see here, that is we have done 0.0416 mole. That was the given initial quantity. So we will take that as the initial quantity and 0.0416 minus, if you want to find excess, we need to subtract it with the amount that is used in the reaction. How much is used? 0.035 is used in the reaction. So tell me what is left behind. If you do this subtraction, that is 0.0416 minus 0.035. So if you calculate it, it will come around 0.0066 mole. So I got the answer, that is magnesium which is left in excess, that is not used in the reaction, is 0.066. What about oxygen? We know that oxygen is completely used in the reaction, correct, since it is the limiting reagent. Now suppose in exam they have given the option not in mole but in terms of mass, then how will you convert this in mass? I can say magnesium in grams which is left excess is equal to, how will you find out that? So we know that number of moles is equal to weight in gram by atomic mass, correct? So tell me what is weight in gram then. So we can say magnesium in gram is equal to number of moles multiplied by atomic mass. So number of moles we know 0.0066 into atomic mass of magnesium, that is 24. So what will be my answer if you multiply this with 24? I will get the answer as 0.1584 gram. So very simple. My conclusion is, now tell me, we have taken 0.0416 mole magnesium is taken, and out in that how much is used in the reaction? 0.035 mole we can see here. So how much is used in the reaction? 0.035 mole of magnesium is used, and the left behind was 0.066 mole. Okay, and if you convert this into gram, the answer will become 0.1584 gram. Even sometimes they can ask you how many molecules of magnesium is left behind. In that case, you need to convert this mole to number of molecules. We know that 1 mole is equal to Avogadro number of molecules. So 0.0066 mole means 0.066 into Avogadro number. So you will get the number of molecules. So I hope you understood the lecture, this question. So this is a lengthy question. Sometimes you could expect questions like this for your NEET exam. If you practice it, this becomes much easier. Okay, so for more lectures, please contact Brainiacs Classes.